Hi, I'm Rich with insideHPC, and we're here at SC12 in Salt Lake City at the insideHPC booth. I'm here with Josh Simons from VMware. Josh, VMware probably isn't that well known in this space, HPC, but I've always figured you can define a company by the company it keeps by the customers. What kind of customers use VMware?
Well, first off, hi, Rich. So, VMware is a complicated company in the sense that we have a pretty vast portfolio, but let me kind of boil that down to its essentials. Our roots are really in virtualization, and it's actually quite interesting. VMware was the company that actually figured out how to virtualize the x86 processor, released its first server product back in 2001, and if you fast forward now, 2012, analysts are saying that roughly 50% of all data center workloads in the world are virtualized. About 80% of those are running on VMware virtualization. So we service a vast number of customers worldwide, including many of the customers that come to shows like supercomputing.
Okay, and I find that interesting because I think I read somewhere that x86 they thought was unvirtualizable. It was going to be impossible, but you guys cracked that code.
Yeah. Actually, the company was formed out of a research group from Stanford, who actually developed a full software methodology for doing that virtualization involving binary translation. It's actually an interesting point because they used a full software approach, and it wasn't until later that both AMD and Intel added hardware support into their chips to actually support virtualization. And the reason that that's important is because performance of applications in virtual environments has been changing on an ongoing basis over the last decade or so as more and more hardware capabilities are added in and as the software increases in its sophistication as well. So we're really at the point now where we're able to address significant fractions of the HPC community's workload requirements, at least on the throughput computing side.
So, Josh, we're both longtime HPC people. I don't want to say how many years, but a long time. But you always go to the technical program.
Yeah.
I always like reading your blog about what your thoughts are. I wonder, do you see any trends this year at SC12?
Well, yeah, absolutely. So the thing that I picked up on, and maybe it's somewhat self-serving because I'm obviously looking at this through the lens of virtualization, is that there seemed to be a real attitude shift between last year and this year around cloud computing. I think there was a lot of questioning and kind of doubt even last year about that. Whereas this year, I don't really sense that. I really I went to a lot of sessions where people weren't questioning the approach. They were actually really kind of assuming that they were integrating cloud into their overall workflow and using it in places where they felt it would add some advantage. So that actually was quite interesting. It seems like we've gone over some kind of a hump there at this point.
Yeah, because it seemed like the old default answer was bah.
Yeah,
right?
Exactly.
Right. So along those lines, Microsoft had a big announcement on Azure and InfiniBand, didn't they?
Yeah, actually, and this was quite interesting, and I'm glad they did it from an ecosystem perspective because so you're right. They announced that they're now supporting InfiniBand. They actually put a virtualized system onto the top 500 list, and the reason that that's important is because they're demonstrating, as we've been demonstrating as well, but they're demonstrating very publicly that it is possible to run for example, MPI applications in a cloud environment, in a virtualized cloud environment. It's not just about running single process applications. And we've done this, these sorts of tests as well. We've shown latencies under 2 microseconds using RDMA. And in fact, actually, I have a colleague in the office of the CTO at VMware who's kind of taking this all a step further and working on a virtualized RDMA interface that will allow direct access to the hardware, but still let us maintain some of the capabilities that are really important in virtual environments, like the ability to do live migration and snapshots, which are really important for delivering the full value of virtualization to
Yeah, I was going to
HPC.
ask you about, because VMware didn't have that support for InfiniBand before.
Right.
Is that in the works or testing already? Or
I'd say it's in the works. It's being deployed at some important customer sites at this point. We've been working jointly with Mellanox on that. Those are not necessarily HPC use cases, but they are uses of InfiniBand on the platform. So yeah, for sure, we're definitely moving forward in that area.
Well, the old stigmas kind of die hard, Josh. But we used to think that if something was running virtual, like virtual disk,
right,
virtual memory, that just meant slow.
That's right.
They were synonymous. Is that changing? Do people are they seeing numbers that? No, this really makes sense.
Yeah, actually. So going back to the sort of single process cases, that would be things like financial services, movie rendering, EDA, so chip design, those sorts of, even some parts of life sciences. The testing that we're doing, and in fact, even if you go and look at the final report from the Magellan project from DOE, you'll see that, generally speaking, those kinds of applications experience under 5% performance degradation, and we've even seen significant cases where in a throughput mode where you're running multiple applications in separate VMs versus looking at it in a bare metal environment, we actually run a bit faster. The throughput can be higher in a virtualized environment. So that all looks great.
Yeah.
So then you go and you look at the InfiniBand side, what can we do there? Mm-hmm. And, admittedly we're doing small scale testing at this point, but we're seeing roughly 15% performance degradation on, say, a CFD code, like a star CD type application. Now that is not to say that's an upper bound. I'm sure we could find, some much more latency sensitive applications that would suffer higher degradations, and I'm sure if we scale higher, we'll probably see bigger numbers. But that is a work in progress. We're putting a lot of effort into latency reduction in the platform, and that's kind of the one thing that we really kind of need to knock down to continue to expand the kinds of applications we can support.
So we know there's going to be some overhead maybe, but what are the benefits, like as we move to Exascale? Why virtualization becomes more important? I've always wondered this question.
Yeah, so for Exascale in particular, there are probably a handful of kind of what we call value propositions for virtualization for high performance computing, but for Exascale in particular, which is not necessarily an area that we're specifically focused on, but for Exascale, this whole idea of resiliency and being able to do comprehensive checkpoints from a reactive perspective, but much more interestingly, potentially being able to tie fault prediction capabilities into a proactive fault avoidance strategy using live migration is something that actually seems quite appealing. And to your earlier question about interesting things at the conference, there was an entire session on 3 really excellent talks on fault prediction, looking at memory systems and just systems in general. And actually I'm quite hopeful that we could produce some telemetry essentially that would allow us to get advanced warning about nodes that are going to go down so that you can actually take action and move the bits off the box before it fails. So if you think about running at an Exascale with a very, very large MPI application, the kind of holy grail there would be you move a rank of your MPI application, fix up the network connections as you do that, and then have that node fail after you've left it. So you essentially dodge the bullet. So rather than writing out petabytes or exabytes of main memory, you're actually dynamically dodging that failure bullet over time, and the application continues to run. Now, I'm not at all claiming that that's going to solve the problem, but what it could do is reduce your reliance on checkpointing, and in conjunction with algorithmic changes and other changes that the community is looking at, could add a component to the resiliency.
Well, this is so important with Exascale because this machine would have millions and millions of parts, right?
That's right.
And storage and everything else, and something's always going to be failing at any given time.
Exactly.
Yeah. So,
that's right.
Well, terrific, Josh. Well, I really appreciate this update.
Yeah, Rich, great talking to you as usual.
Oh, man. And we'll see you next year in Denver.
Looking forward.